Once again, good morning and welcome to our Stat and Prob class. This morning, let's start with chapter 2. And chapter 2 is talking about normal distributions. And let's have the introduction for the first lesson. Our memory verse is found in Genesis 50, verse 3. It says, "It took 40 days to complete the process, the normal period required for embalming. Meanwhile, the Egyptians mourned for him for 70 days." The keyword is normal. What is the normal period for embalming? If they say it's for 40 days. And in real life, we have some normalities, like the normal height, the normal mass, the standard, we say normal or standard pricing. And this morning, we'll learn more all about these normalities. At the end of our class, we'll be able to illustrate a random variable and its characteristics and construct a normal curve. And here's our venture with me activity for today. It's about the cornfield. Normally, in a cornfield, you don't see uniform heights, right? There are tall ones, there are short ones, and most of them are having heights between tall and short. This is one of the applications of a normal curve. Like for example, if you see normally, not all are tall, not all people are short, but most are in the average. The same with examinations. In an examination, they say it is normal when only a few will get high scores, a few will get low scores, and many will be in the average. That's why we say it's not normal if in your examination the results are only a few would pass and majority are failing. That's not the normality. So normally, many are in the average and few are in the extremes. Now, let's talk about the definition of a normal curve. Now, what is a normal probability distribution? This is a distribution of data where the mean, median, and mode are all equal. And the distribution is clustered at the center. The graph of a normal distribution is a bell shape. It means it has a stiff peak and the graph is symmetrical. Now, here are some properties of a normal distribution. The first property is the distribution curve is bell-shaped. It can be a high peak, it can be a flat as long as it is a bell-shaped. Second is the curve is symmetrical about its center. If you see here, this is called mu, or we say that is zero. It means mean. Now, we have 3 to the left and 3 to the right, and it's symmetrical. If you cut it into half, the other side is the reflection of the other. The third is the mean, that's the average. We call it mu. The median, that is x bar, not x bar, x tilde. Let me now write here. We say the mean, for some it's x bar or mu. The middle score, the median, x tilde, and the mode, we have x hat, are all in the center, all in 0. Next, the width of the curve is determined by the standard deviation of the distribution. A curve can just be small or it can be very wide. It depends on the standard deviation. Remember before we have the sigma, right? What is the sigma? It's a standard deviation. How wide is the gap from one score to another? Next, number 5. The tails of the curve flatten out indefinitely along the horizontal axis, always approaching the axis but never touching it. The curve is asymptotic to the baseline. It means that in these ends, we say in the tails, these are asymptotic. It means it never ends. And the bell, the tail of the bell will never touch the horizontal axis. It might be very small distance, but it never touches. The sixth one, the area under the curve one represents the probability of proportion or the percentage of the distribution. These are synonyms. If we say probability, it can also mean proportion. It can also mean percentage of the distribution. So for example, we say, what is your chance? What's the probability that you will pass stat and prob? We say 50%. That 50% is called probability. It can also be called proportion, and the other is also percentage. Feel free to raise your hand if you have questions. Now, here's a definition of the standard normal curve. The standard normal curve is a normal probability distribution, and here the mean or the mu is 0 in the middle. And the standard deviation, or we say the gap, is 1. So we say that's 1, 2, 3. To the left of 0, we have -1, -2, -3. The gap is 1. And there are 7 standard deviation units at the base of the normal curve. They're from -3 down to +3. Now, let's go to the next page. How do we find the areas under the normal curve? Here's how you're going to do it with a 4-step process. First is, for example, we express the given value in a 3-digit form. So example 1.87. The next step 2, using the Z table, find the 2 digits in the left column. Example, we're looking for 1.87. So in the left of your Z table, we have 1.8. Then the third number should be seen on top. So 1.8 and 0.07. It becomes 1.87. So we now have you check their intersection. The area is 0.4693. Any questions? No questions? Let's go to the next one. Let me share later my Z table. Another one, example, you need to find the area that corresponds to Z equals 1. So you make it 1.00 because there are no numbers next to it. The first two, 1.0, find it in the left column there. Then your last is 0. Find the intersection. We have 0.3413. The next, 1.36. So 1.3 on the left and 0.06 on top. Their intersection, we have 0.4131. The last one, -2.58. Remember, area is a scalar quantity. So it means that the answer is always positive. Like for example, you don't say, how big is your land? 5 hectares. How small is your land? You don't say -1 hectare, right? See, still 1 hectare. So it's always in positive. Area should always be in positive, even if the given Z is negative. So you have negative 2.58. You just take the positive value, 2.5 on the left, and 0.08 on top. Then their intersection here, we have 0.4951. Any questions? No questions? Now this time, I want you to look at this Z table. Wait first. Let me share another. Hope you have your Z table with you. Okay, get your Z tables, please. And let's have a very short drill. In the chat box, you share with me. Okay, let me make this one bigger. Sorry, not the chat box. Okay, ready? In the chat box, share with me. What is the area under Z equals 2.05? 2.05. What is the probability? So we have 2.0, and that's 5. Intersection, I only count it here. 0, 1, 2, 3, 4, 5. That's 0.4798. Congratulations, you have Carl. Actually, I'm scoring here. So whoever will get the most number of scores, that will be your bonus points for today. Now next, we have 3.15. Z equals 3.15. Go. Okay, we have 0.4992. You check. 3.1, then 0, 1, 2, 3, 4, 5. 4992. Very good. Still, sorry, I only score the first person who can give me the answer. Another point for Carl. Next, let's have Z equals 3.09. Z equals 3.09. Go. Gauna ko rin signal ni Carl. The answer is 0.4990. Another point. Next, second to the last. Z equals 0.5. Go. Z equals 0.5. .5? Oh, sorry, Jewel. It's the wrong answer. The first one to post is still Carl. 0.1915. Here, 0.5, this one. Next, the last one. Z is equal to 2.69. Z is equal to 2.69. Very good. That's 0.4964. 2.6 and 9 here, that's 0.4964. Congratulations for this lesson, Carl aced it.